Welcome. Today we're going to learn to solve multi-step or two-step inequalities. Now, with an inequality, it's not much different than solving an equation, like a two-step equation, except for one aspect, and that's if you multiply or divide by a negative number, the inequality symbol flips. And now I want to give an example of that. If you think about this, if I go 3 is less than 10, you should all realize that's absolutely true. 3 is less than 10. If I add an amount to either side, like add 5 and I add 5, the number on the left side of the inequality is still going to be less than the number on the right side of the inequality. 8 is still going to be less than 15. But if I take that 3 that's less than 10 and I times, well, first of all, let's times by a positive. Let's say I times both sides by a positive 5. Well, 5 times 3 is 15. 10 times 5 is 50. The number on the left is still less than the number on the right. 5 times 3, or 5 threes, is definitely going to be less than 5 tens. So 15 is still less than 10. But here's the catch. If I take that 3 that's less than 10 and I multiply both sides by a negative number, let's say negative 2. Multiply by negative 2. Well, negative 2 times 3 is negative 6. 10 times the negative 2 is negative 20. Now remember, to be considered less, it has to be further to the left on the number line, or the larger in magnitude a negative number is, the smaller it actually is. So if you'll notice, the inequality symbol, you have to flip it, because now the right side, which is negative 20, is less than the negative 6. And the same thing applies with division. If you multiply or divide a negative number on an on an inequality, and an inequality, that inequality symbol must flip. So let's do some. And again, it just takes practice, and it's just remembering that you're working with inequalities rather than with equations, because with equations, it doesn't flip. So let's take this first one here that I'm showing. This 4 plus 3k is less than negative 5. Again, the first step is we want to isolate the term that has the variable, the k. So I'm going to minus 4 from both sides. And adding and subtracting never ever changes the inequality symbol. So when I minus the 4 from both sides, the inequality symbol will stay the same. And I get 3k equals negative 9. Now I'm going to divide by a positive 3. Divide by a positive 3 in order to eliminate that multiplication of 3 that's multiplied by the k. And if I multiply by a positive, it does not change the inequality symbol. So k is less than negative 3. So in that whole process, I did not have to change or flip the inequality symbol. So let's do one more like this, and then maybe I'll just jump ahead. This one, we have 8m is plus 6 is less than or equal to negative 2. Again, first thing I'm going to do is isolate the term that has the variable. So I'm going to minus 6. That gives me 8m is less than or equal to. Now, minusing does not change the inequality symbol, so it's negative 8. Now I'm going to divide by a positive 8. Divide by a positive 8. Since I'm dividing by a positive number, that does not change the inequality symbol. So m is less than or equal to negative 1. So m, and make sure you're careful that you put the exact same inequality symbol that's up there, as long as it doesn't need to be flipped, because you're multiplying or dividing by a negative. So I'm going to skip ahead because I'm sure that they get to some that have negatives. Now here, I would highly recommend that you get in the habit of keeping your variable on the left. There is nothing wrong with keeping it on the right. I'm going to do it both ways very quickly so you can see that why the inequality symbol would flip if you divided by a negative. What I mean by that is I'm going to leave first that t term on the right side of the inequality symbol. So I'm going to add 8 to both sides, which does not change this inequality symbol. And negative 19 plus 8 is going to be, oh, sorry, that's not an 8. That's supposed to be a 3. It's like I wasn't going to come out nice. That's a 3. So negative 19 plus 3 will be a negative 16. And since I, again, added positive 3 to both sides, or added, doesn't matter if it's positive or negative. If I add, you do not flip the inequality symbol. Now I'm going to divide by a positive 8. Since I'm dividing by a positive 8, I do not flip the inequality symbol. And I get negative 2 is less than or equal to t, or t is greater than or equal to negative 2. Now, let's take that exact same equation, negative 19 is less than or equal to 8t minus 3, and let's bring the 8t to the left side of the equation. Let's say we like to keep the variable on the left. So I'm going to minus 8t from both sides. Minus 8t, which is not a like term with the negative 19, so I'm going to be left with a negative 8t minus 19 is less than or equal to negative 3, because those two cancel. Now what I'm going to do is add 19 to both sides. Those cancel. Now adding, again, that doesn't change the inequality symbol. So I have a negative 8t is less than or equal to negative 3 plus 19 is positive 16. Now be careful here. I have a negative 8. I'm going to divide by a negative 8. Divide by a negative 8. Now if I divide by a negative 8, I'm left with a t on the left side, and I'm left with a negative 2. Now remember, over here, that t was on the larger or the greater side. If I left the inequality the way it is, it would be putting it on the smaller side. So again, if you divide or multiply by a negative, this inequality symbol is going to flip. It's going to be t is greater than or equal to negative 2. Now, when you're doing this, if you like to leave the variable on the left, there's nothing wrong with that. In fact, I believe this system will even let you leave it on that side. So I'm going to plug in the negative 2, use this one over here, so the less than or equal to t, and see if it accepts it. And it did. It accepted it just fine. So now here's another one. Be careful. We have a negative a involved. So we end up having a negative, in a sense, 1 that we got to remove. So again, this is one where if you were to leave that a on the right side, you're going to end up having to multiply or divide by a negative 1. So in other words, if you left the a, I'd add 7 to both sides, get 2 is less than negative a. I didn't flip because I was just adding and subtracting. You never flip. Then what I'm going to do is I'm going to get rid of the minus sign and think of it as a minus 1 times a. So I'm going to multiply by a negative 1 on both sides of the equation. Negative times a negative will cancel, leaving just the a. Negative 1 times 2 is a negative 2. But since I multiplied by a negative, this inequality symbol must flip. It's going to look like this. Now, let's do that exact same equation again, where I'm going to move the a to the left side. So let's do that. Negative 5 is less than negative 7 minus a. Okay, so now what I'm going to do is I'm going to add a to both sides. Again, not like terms. So when I add them, I get an a minus 5 is less than negative 7. Sorry, I'm trying to get this closer to the computer because the camera's set up. I got to adjust my camera at some point. Now I'm going to add 5. Again, a is less than negative 2, which is exactly what we had up here. A is less than negative 2. And remember, I had to flip that inequality symbol because I multiplied by negative. In this way, I never did flip the inequality symbol because I just added the a over, added the 5 over, and I didn't need to do any multiplication whatsoever. So I can come up here and do a is less than negative 2. So just remember, as you're working through these, if you ever multiply or divide by a negative, the inequality symbol flips. Adding and subtracting, it never does. and multiplying and dividing by a positive, it does not change. Only multiplying and dividing by a negative. If you have questions, please let me know and I will help you in class.